Hi, welcome to Our Math. Today I am doing a video on calculators, specifically in regards to finance equations. This is a how-to on calculators I like, calculators I use, and how to use it for big finance equations. Now, in a finance class, there are several finance equations. There is simple interest, and I will say with simple interest, only use this if you are told to use it. So I'm going to kind of wrap into this a little bit of review or preview for these equations. So only use it if the prompt tells you to use simple interest. There is A equals P1 plus RT. There is I equals PRT. And then, of course, this one is the hard one. And the reason this specific equation is the hard equation is because this one says interest equals principal times rate times time. And you will get a prompt that says, find the interest of, and you're going to want to use that. But if it doesn't say simple interest, don't use that equation. And then there's one that says A equals principal plus interest. A is your final amount. Okay, so those are your simple interest equations. Yay, simple interest equations. Next, we have compound interest. You know, you're like, where are the calculators? And like I said, I want to add a little bit of a review or preview. Compound interest is one that you have probably seen in myriad math classes. This one is A equals P1 plus, so R over, I'm going to use M to the MT. Often it's N, so M versus N. Different books use different variables. I teach both depending on the class I am teaching. Either way, this is just number of times per year. And it's always an integer. So if it's monthly, it's 12. If it's quarterly, it's 4. It is never a decimal. It's never a fraction. It is always an integer. The thing about this is it's really simple to put into your calculator. The one trick that you need to do with this when you're putting it into your calculator, and I'll show this on a calculator in a second, if you have an example, and we'll have a generic example where the principal, let's say, is $5,000, and we'll say a rate of 5%. And so if we have a 5% rate, then rate, we always want to put that as a decimal. So 5% is per 100, cent, 100 pennies, 100 cents in a dollar is 0.05. And then we'll say compounded. Again, this is number of times per year. We could say monthly, we could say daily. We're going to, by the way, daily is in a math class is always number of days per year that we talk about, so 365. We're going to do monthly. So we're going to say that M is equal to 12 because this is monthly. And we're going to say T is, let's just do 10 years. So for this one, there are two ways that this would get typed into a calculator. The first way that we would type this into a calculator is we would say 5,000, A equals 1 plus, now this is just division, so 0.05 divided by 12. I wouldn't use a fraction button there, I just wouldn't. And then I'm going to do a little caret because that's a cheap calculator button. Parenthesis, we got to put that 12 again because this is saying the rate is applied 12 times a year. And so you take that, this is annual divided by 12 to find out the monthly rate. And then you have to do it 12 times a year. And then we do the times button for 10 years. So what that's going to look like when we enter that in here is 5,000 parenthesis 1 plus 0.05 divided by 12. And then the caret button is down here. There's our little caret. Parenthesis 12 times 10. And there we go. We have our answer. $8,235.05, 0.0475 cents. The thing is, if you have a calculator, this one is roughly the same. Casio FX 115ES, Casio FX 300. The only difference between the 115 and the 300 is the 115 can handle imaginary numbers. That's the difference. They both cost roughly the same amount. I am going to start off the same. I'm going to say 5,000 parenthesis 1 plus 0.05 divided by 12. This time I don't have a caret button. I have this X box. That is going to pop up my exponent up here. I don't need parentheses now. Because it's popped up, I don't need exponents. I can just say 12 times 10. And I get that same answer. Same 0.047. It gets rounded up to 0.05. Same. And the same thing is going to happen on the graphing calculators. Yes, I'm not forgetting those of you with the big calculators. This is my son's, which is why it has the dead zone. I will say this one is going to work like this one, because when I put in that little caret, I have that same caret, so it's going to work the same way. The way you can tell which of the two calculators this calculator will work like is if you hit alpha y equals, this pulls up the lines. If you hit alpha y equal and you get something that looks like this, N over D, or it also options off this fraction-y bit, then you have a calculator that works like the Casio. You have the TI-84 newer version, which is a little bit nicer. Okay, so that's fun. Now let's talk about why calculators matter. Probably everything I've done here, you're like, yeah, that seems pretty simple. So then we have our annuities. And the first one is the future annuity. So I'm just going to call it a future annuity. It's actually an ordinary annuity. Here we go. A equals R. 1 plus R over M to the MT minus 1 over R over M. Now, if you're thinking this looks like this, it does. I have a video explaining why. And if you're thinking, whoa, that looks ugly, kind of is. It's big. It's a lot there. I know that. You can see that now. So this R means periodic payment. These are both lump sums. So for both simple interest and compound interest, it's a one and done. You put it in the bank and you're done with it. One and done. That's how you know you're using those. For the annuities, there is a periodic payment. You put $25 away every month from your paycheck. There is something that happens on a scheduled. So scheduled. This is, you start at 0 and you go up to money. So the future annuity is just that, you're building to a future. This is also the ordinary annuity. So let's take the same, well, we can't do the same. We need an R, because we're going to figure out what this A is here. So let's say that you, just what I just said, we're putting $25 away. Same bank, 25%. We're doing it monthly. We're doing it for 10 years. So most of the rest of it is going to be the same as what we have set up above. Sorry, I gotta get around all my other doodads. So A is equal to 25. 1 plus 0.25. I should have done two numbers. Sorry, 0.05. 0.05 over 12 to the 12 times 10. So looks very similar here. Minus 1 over 0.05 over 12. I'm going to start with this calculator. So one reason I like this calculator is what I just cleared off. I can do something that looks very much like this. I can say 25 times, and then I'm going to hit this right here, this fraction button. So I'm going to say fraction. And what's going to happen is I'm now going to be able to put this in just like this. So parenthesis, 1 plus 0.05 divided by 12. And notice I don't do the fraction again. It just, too many symbols in there. I pop up to the exponent, 12 times 10, arrow out to get out of my exponent, minus 1, drop down, 0.05 divided by 12 equals, there we go. So if you put $25 away for 12 monthly for 10 years, at the end of 10 years in your bank account, you have $3,882.06. Okay, so let's talk about this calculator, because things are going to be a little different here. You don't have that fraction. You don't have kind of those extra bits in here. So what's going to happen here? So for this, we are going to type 25. We need a parenthesis for the numerator. We need a parenthesis for this parenthetical phrase. 1 plus 0.05 divided by 12. That's parentheses to close off this parenthetical phrase. Caret, open parenthesis for the exponent. 12 times 10, that's to close off the exponent, minus 1, that's to close off the numerator, divided by, that right there is for the fact that the denominator has extra math in it, 0.05 divided by 12, close parenthesis. So 2 open, 1 close, open, close, close. That's all for the numerator. Probably should put a times there because we're multiplying there. All right, so let's see how this all looks. On and clear. 25 times open, open. 1 plus 0.05 divided by 12, close. Caret. Open, 12 times 10, close, minus 1. Minus 1 is what most people miss. Divide. Open, 0.05, divide 12, close. We have it all in there. We hit equal. And we have that same answer, 3882.06. The Casio, it was a little easier if we didn't get the right answer to see what was going on, but we can do it. We just need to be more conscientious of the parentheses, numerator, parenthesis, close parenthesis, caret, exponent, parenthesis, parenthesis. Don't do the parentheses like this, do the parentheses like this. Okay, so the last annuity we have is the present value of an annuity. And this one is, this is often used, and this is not the full list, but it's often used for loans. It's often used for, so a car loan. It's often used for mortgages, so a house loan, so loans. It's often used when you have money in a bank and you're pulling it out, like, I have saved $10,000 and I want to spend it over the next 4 years. So this is basically used for when you have money and you're bringing it down to $0. So they're exact opposites. This is zero, building money to the future. This is I have money. So like retirement. This is also used for retirement. You know, I have a lot of money and I'm going down to zero. The formula that we are using, there's two versions. The one I'm going to be using is R 1 minus parenthesis 1 plus R over M to the negative MT all over R over M. Lots of negatives here. I always think of this negative as we're chipping away. The negative exponent is because we're going down. Again, the R is a periodic payment, and this is used usually for loans and retirement. So if you see a car loan, if you see a retirement, if you ever see how long until it's paid off, anytime you're looking to go to zero, this is the formula you're going to use. Okay, so let's again set this up. We can do the same thing. This time it would be like a $25, let's say you buy a car. And the question isn't so much in this case. Remember I talked about interest and simple interest. The question is really, how much are you going to be paying over the life of the loan? So let's say you buy a car and your payments on your car are $125 with a rate of 5%, and you're paying it again monthly, because those things are pretty common. So yeah. So we have A equals $125, 1 minus 1 plus 0.05 over 12 to the negative. That negative is often what is missed. 12 times. And let's say, let's not make it a 10-year. Let's make this a 3-year loan, because that's more common for a car. 0.05 divided by 12. Okay, so we have all our numbers in there. See how it looks on this calculator. 125 times 1 minus 1 plus 0.05 divided by 12 to the, when I do the negative, I'm going to do the negative over here. Negative 12 times 8. Go out of the exponent down to the bottom, 0.05 divided by 12. And I am going to get 9873.68. All right. So there we go. And then if we look at our other calculator, did I do 3 or 8? Let's try that with a 3. Delete 3. Ha! Okay. That makes way more sense. Okay. I was like, that seems really wrong. 4170.71. Okay. There we go. What is this telling you? This is telling you that this is the original loan. This is the loan that you are taking out. So this is the original loan. You took out a loan for a car that costs $4,170.71. If you want to know what you're paying out of pocket, you're paying $125 for 12 months a year for 3 years. You're paying $4,500. Now, if you want to know the interest, remember we talked about interest. Well, you've paid this much, $125 for 12 months for 3 years. This is the original cost of the car, $4,170.71. If you subtract them, or 170.71, the interest that you've paid is $329.29. By the way, what I just did there, if you just got this calculator and you're like, what's going on? There's a button right here that's specific decimal. And if you just click that button right there, it will toggle between the forms of specific and decimal. All right, because this video is getting way longer than I meant it to be, let's talk about how you put this into a non-fractiony calculator. So once again, so this is present, future. Let's talk about the present. A equals 125. We need a parenthesis for the numerator. Then 1 minus parenthesis 1 plus 0.05 divide 12 caret. Now we need parenthesis for the exponent, negative 12 times 3, close parenthesis for the exponent, close parenthesis for the numerator, divided by denominator, 0.05 divided by 12, close parenthesis. Okay, so 125 times open parenthesis, 1 minus open parenthesis, 1 plus 0.05 divided 12, close parenthesis, caret, open parenthesis. The negative is all the way at the bottom, right here. There's our negative sign. 12 times 3, close parenthesis, divided by 0.05 divide 12. And we have a syntax error. Oh, no. Okay. Oh, I didn't put an open parenthesis right here. Okay, there we have the same answer. Notice I labeled a $sign in all of my things, and we found our syntax error. I hope you enjoyed this video. Sorry, it was almost 25 minutes. I didn't mean for that to happen. Like my video, like my page, and I'll enjoy my other playlists, and I'll see you on the next video. Bye!